Hey guys, welcome back to our TransCADTutorial4. Welcome to our extra part. In this part, we're going to do TransitSkim. Using that, we will generate the transit input to mode split, which was what we did last time. So this workspace was the file we used last time, and these are all the inputs. The inputs we have had was first this map and with just a layer of zones and with the table behind it. So that's nothing new to us. I can minimize it now. And we also have this input, which is the OD matrix of all our OD pairs. So this is the output from trip distribution. So also nothing new. And this another input is the car table. We call it car cost table last time. It's a matrix telling us the travel time for the shortest path of all the OD pair. And this was also generated by our tutorial 1 and tutorial 3. So we were using network, create a network, and just then run multiple paths, and we got this. So also nothing new. The only thing new was this table. We call it the bus cost table last time. This is a matrix table. For every OD pair, you can have the bus availability, whether it's possible or not to travel by transit for that OD pair. We have the in-vehicle travel time. If it's possible to travel by bus, then what is the time traveled in the vehicle? What is the number of transfers? If you have to transfer among the routes, what is the fare? And things. You can have even more if you want. So we were using this as one of the input last time. So the question is, where does this come from? This is actually from a step in this transit called skimming. It's called transit skimming, and that's what we're going to do today. All right. So we can close everything and open a new file for transit skimming. So for me, I'm going to open a root system file .rts here, and it's called transit. So what I have here is nothing but 5 basic geographic layers. This is the least you should have if you want to do transit skimming yourself. I can hide all of them. So the first 2 layers are the node layer and the street layer. We have seen this before, of course, just intersection for the node and also the centroid of our TAZs, which we can, this file has not selected that for us, so we can do it by ourselves. We do, with the node being the active layer, we do selection and select centroids, and we do OK. So with that, we can have some nodes selected like this. It's a centroid of a TAZ, and also we have some connector links generated by the way, which is a subset of our link layer, it's the connectors. So we have seen this before, so that's easy. And on top of this link node layers, we first have a layer called root system. You can show it here. These colorful lines are the route. There are buses and trains in Washington, D.C., WMATA transit system. And we can have a look at their table. We have only 20 different routes in our tutorial example. So we have first their ID, and then we have the name. Here we can see the first 2, for example, we have orange line, one on left and one on right. So that means we have 2 different routes for one line. Back to the map, if we click on this line symbol here, and to here, root settings, we can change the style. So right now the offsets, it's on center line. That means the two directions of one line will be plotted together along the center line like this. So we only see one line there. And if we choose right or left of center line, click OK, then we can see for every root we will have two directions. And specifically for here, for this segment, we have two orange lines, which are these two we have seen here. And we also have two blue lines, left and right, which are this root ID 3 and 4. So that's the root. We have some other fields in the table, like for CC style, that's the color. So 1 in this case is orange, 2 is blue, just for the painting. And for mode, in this table, 1 means train, like orange line and blue line, and 2 means bus, like X1, G8, H2. I guess they're the names for one-motor bus. And we're going to use this mode field later because we are going to look at the fare system. Buses and trains, they have different fares, and also the transfers fare are different. So we're going to use this mode field. And we also have like headway of the route, variance of the headway, and the fare. Here we already see bus is $2.15, and train is that price, and bus is $1.5. Yeah, so that's our route system. And here we have another layer called stops, and also another layer called physical stops. These two layers are both describing stops in our transit system. And they are different in that a physical stop is literally a physical stop. You can understand it like this metal plate on the post out there. That's a bus station. That's one physical stop. But in this physical stop, we have two stops for routes. One stop for route 89, one stop for route 101. So this one physical stop has two route stops associated with it. So that's the structure. Physical stop is our station, and the stops layer is the individual route stops. We can show the stop layer on the map. Let's say we zoom into here. We have a little dot here, that's the stop. It seems to be only one, but actually there are 4 of them. So if we first go back to the root system layer and click the info button, we select this range to select, then we are selecting 4 routes at the same time. Just as what we have seen, we have orange line 2 directions and blue line 2 directions. So that's 4 routes. And in our table, their ID is 1, 2, 3, 4 respectively. And if we switch to the stop layer and do the same trick, then we actually got also 4 stops. The stop with ID 1, it belongs to route ID 1, and this stop belongs to route 3, and this for 4, this for 2. So we have 4 stops here for the 4 routes here. I hope that helps you understand the transit system structure in TransCAD. And we can also show the physical stop. That's nothing much but another circle to surround our individual route stops. So nothing much on that. And further, our stops are actually there are also associated with the roots around them. We have already seen each station belongs to a route ID from 1 to 20. That's all our routes, and has some other features here. Most importantly here, this field called near node, that is associating each stop with a closest node within some range of it. The node we're talking about is in this node layer. To show you clearly, we can temporarily hide the root system. So back to our stop 1, for example. If we open the table, stop 1 with the ID 1, the near node is 15874, which is actually this node. So if we go to the node layer and do the info for this, that's 15874. Intuitively, this node is This node is very close to our stop, which is why it's called near node. So why do we need this? Because when we let the software to calculate the shortest path for each OD pair using the transit system, this bus or train stops, they are not directly part of the link and node graph, which is used for the calculation. So for that, for the mathematical model to run, TransCAD needs to represent each stop in the system by a node near it. It's just for the model to run. And this column, for your project, your data, if you don't have this near node field for yourself, then you can actually generate it. I can show you how to do that. So pretending we don't have this field, for this matrix, for this table of stops, we'll do data view, table, and modify. We'll first add a field, near node new, gonna be an integer. Yes, so we created this new field, and we're going to fill it by transit text stops node. If your text stops node option is grayed out, then make sure your current active layers node. If it doesn't work, just maybe have the root system back and select the root system. Make sure this is workable for you, and you click on it. Then what this says is that for each stop, it will search for in a range distance of 0.2. You can change it. And once it finds the closest node for that stop, it will store it in the field of near node new. Click OK. And now we have these numbers. We replicated our data. Okay, so that's how you generate that. So with this, you see the stops are associated, the stop layer associated with our node layer. And the stop layer, they're actually also associated with the root layer. And the root layer, pick anyone. Let's say this one with this very strange, weird shape. This root layer is also associated with the link layer, the streets layer, call it. So we can hide the root system. You see that? Bring it back. For the root here, we actually have link beside it. So they are associated. So actually, the root here can get some fields or features from the link beside it, like the travel time, the direction, and anything like that, which will be used in our later calculation for the transit skimming. All right. So the transit structure in TransCAD is obviously more complicated than just the car network. So you need to be careful about it, especially when you need to make editing on your route or stop layer. Then you have to make sure that after your changes, everything is still connected correctly. Your route is not broken in the middle. Your stops know where they belong, where they should go, and all kinds of things. All right. And just one last thing before we do transit skimming, we want to come to our street or link layer. Here you want to make sure that you have the walking time for the links. Again, if you don't have it in your data, then you can just create it by table modify and add walk time new, and you can fill this new row by this time maybe a formula. So you would use the length of the link divided by whatever a walking speed should be. I don't have a number here. Let's just say 0.1 or whatever makes sense. And click OK. Then you will have the number. All right. Just in case. Oh, sorry. I didn't fill it in the right place. Let me clear that. The fill. Okay. I was using the wrong one. Sorry. Length over whatever walking speed is, and you will have the number for that field. This will also be used by later the calculation. All right. Then I'm not gonna save it. Okay. So now we have all the geographic files ready. We are going to assume that they're all of good quality, ready to use, and we will do transit skimming. So the first step for transit skimming is to create a network for transit, which is called a transit network. And if you still remember, for the car network, when we are calculating the shortest path, the first step was also to come here and create a network. So here, what we're doing for transit is very similar. So on the map, we should make the root system the working layer, and then transit, create network. And here we have a lot of things to select. For the input tab here, the routes, we are going to use all our 20 routes, all the stops. Mode field, we're going to use this field called mode, which is 1 for train and 2 for bus. And read length from field of length and stop to node field. That's our near node field we created before. And then transit mode field, just the walk mode as selected here. We'll talk about this later. And here, among these tabs, we need to select some available fields. For the link fields, we must have the in-vehicle travel time. And for route fields, let's get the route, mode, head width already there, maybe the variance and the fare. And stop and nodes, we can leave them. And non-transit, here, what this non-transit means is that normally for most of our public transit trips, there will be some non-transit part in it. Usually it's the beginning and the ending of the trip where a person needs to walk from home to the station, something like that. And here we assume there's no car trip for that. People all walk for that. And here, for the walk, we will need to select which links can these people walk on. And here, it's automatically selecting connectors for us, which is 217 links. These connectors are here. This is the subset of our link layer. These are created or selected when we were choosing the centroids. So they are just the orange dashed line. So if it's selecting this, then in this transit network, people will only be able to walk on this 217 links and not anything else. Therefore, this selection will be horribly wrong. Please make sure that you are changing it back to all links. Of over 8,000 links, we should allow people to walk on all of them so that they can find their way to the bus or train stop. Okay? And for attributes, here, what we're changing is that for some attributes of links, it might be different when the person is riding bus or train as opposed to the person is walking on it. So the length of the link will obviously be the same, whatever mode, but the travel time will be different. For transit, the travel time will be in-vehicle travel time. But when the person is walking, then the corresponding travel time should be changed to walk time. Okay. So that's it for our setting up, and we can click OK. And I'm going to save the transit network as a TNW file. I'm going to give it this name and overwrite my original file. Okay, so now in the status bar, we see the transit network.tnw is active. So now it's ready, and we can do transit skimming. So before that, I just want to help you review what this skimming concept is. Use milk as a metaphor. If you buy a whole food milk and you boil it a little bit, then you will get a layer of fat on top of the milk. So that is called a skim. The milk is the main thing you want, but that layer of fat, that is something like a byproduct. You don't want it initially, but it's yummy, so you can take it. And here in our context, it's the same. Given this transit network we have built and generated, now we can let TransCAD find the shortest path using transit for each OD pair. So that trip profile is what we need. That's our main product. That's our milk. But along the way, given the trip profile for each OD pair, we will be able to tell how many transfers and how much is the total fare and how long is the in-vehicle travel time and all kinds of things like that. These are the byproduct, and that's why in this context it's called TransitSkim. So what we do is to get all these variables we want. Okay. Even before that, we also need to make a setup given our created transit network. Should switch back to root system as our active layer and to transit network settings. And here, Pathfinder, this is going to be the tool we use to select the shortest path of transit. So we click that. We're making the setting up with this. So here in the mode, we will need to open two tables. So let me open them right now, just for you to know what we are doing. The first is called mode table. The second is called, they're both binary file. The second is mode transfer table. Okay, so mode table is nothing special, but just for train, bus and walk, we have 1 to 3 as their mode ID, is the reference table. And here the mode transfer table. This is the transfer fare policy of our example. If you're transferring from train to train, then you don't pay anything. If you transfer from train to bus, you pay $1. Bus to train, $1. Bus to bus is free. So that's our policy. And when we are doing TransitSkim, TransCAD will calculate the total fare for each trip. Then we want it to reference to these two tables to correctly calculate the transfer fee. All right, and we'll check the result after it's done. So now we should go back to transit network settings, pathfinders, to make this setup, because TransCAD doesn't know how to use these two tables yet. Here, first thing in the General tab, we should choose, check this Create Centroids from Selection Set, which is our 60 centroids, right here. And then to Mode tab, first Mode Table, tell you the reference table. Mode Table is here to select. It's in the drop-down box because the table is opened, so it's picked up. And the content is here, nothing to change. And then the mode to mode transfer table, we select mode transfer table. And all these columns are perfectly aligned because these names of the fields are what I want. So that's all for the setup, and we can click OK. And the setup is finished. Now we can finally do transit skimming. So we should, on the map, we must make node the working layer. Otherwise, this skimming will not be available. All right, so now it's available. We'll do transit, skimming, and pathfinder. This is our tool. Okay, this will be very easy. The origins and destinations, we are using the centroids, only 60. And then here we can select variables to skim. In our utility model last time, for bus, we had in-vehicle travel time and fare, these things. So when you are doing transit skimming, this will be the things you want. Fare, in-vehicle travel time. And if you want, you can include other things, just if you think they will be probably useful in your logic model, whatever you want. So maybe here I can also have this initial wait time and number of transfers. So that's all I want, and I click OK. And here the output will be a matrix file. So here you need to choose where you want to store it. I'm going to store it in this folder and give it a name. I can change the name to whatever. Okay, overwrite my original file, and now okay. So this is our result. Let me put the table like this. So this matrix table, our result, we have across the tab different results, like fare. For all these OD pairs, people pay this much, and so on. And the number of transfers, 1 time, 0 times. This missing value will mean that the corresponding trip is not available using transit. And in-vehicle travel time in minutes, and initial wait time based on the headway of the routes. Okay, so these are the things, and this matrix will be our final result. So now let's just pick one of the results and have a sense of it. For example, this one we're looking at. From this node 15850 to this node 21400, the result says there's 1 transfer, and the fare is $2.15. So what does it mean? According to our transfer fare, and also coming back to the route system table, the fare of train and buses, I would say that for this particular trip, it's a train-to-train transfer trip. This person has to pay the $2.15 for the first train and then transfer for free to another train, and that's it. So we can use another tool to get this particular trip on the map in an interactive way and then see if that is correct. The tool we are going to use is Transit, and just above the skimming is interactive pathfinding, and using the same tool, Pathfinder. Here we are going to use this small flag to select these two nodes on the map. So let me make it bigger. So we can click on, let me also hide the route for now. I already know where they are on the map, so I click on the button to first select our first node. The first node is here, this centroid, and the second is down here. You have to do this very, very carefully, because if you click on not the central node but some other intersection node, then the software might crash. Just for your information. Hopefully it doesn't crash for you. So this is our second node, which is the destination. And we can click on this button to find the best route. And OK. Here we go. This box shows us the route just like what you have in your Google map. And the total from this node to this node, total travel time is 32.8 minutes. And here's a direction, which is like the profile. First, the person has to walk for a little bit and then go to section 2 or 3. So if we choose 2, the person will board the orange line and ride a little bit and get off at this stop and go to section 4, which is transfer to a yellow line, and then walk and done. Otherwise, from here, if the person chooses 3, then that's boarding the blue line and then transfer to a yellow line and then walk and done. So the person has 2 choices. It's either orange line to yellow line or blue line to yellow line. Whichever is chosen, it's a train-to-train transfer, just like what we guessed is. So that's why the fare is 2.15 for the first train leg, and then 0 for the transfer, and that's what we see in this final result table. So that's correct. And we have other numbers, like here, from the same margin node to this node is 3.15. So you can easily guess this is a train to bus trip. 2.15 for the train, and then $1 to transfer to bus. And inversely, from this node to this node, that will be right here. It's 2.5. As you can guess, it's not symmetric. So the inverse of this will be a bus to train trip. So the person has to pay first $1.5 for bus and then $1 for transfer to train. So the total is 2.5. So the same trip, the 2 directions have different prices, just the way it is. Okay. So that's what we want for our result. So you can just minimize or close these windows for now. This is what we want. And there are all these things. So this matrix table, you can save it and use it as the input for mode split, just like what we did last time. And here, I also want to show you a little bit how to mess up with this thing. In mode split, along our tabs here, if you remember, we also have a table called availability. So that is not directly generated from here. And I guess the easiest way to have it along with us is simply to create it by ourselves. So we'll just do data view matrix contents, and along with all these things we already have, we add a matrix, and we can rename it as availability. And we switch to so availability is empty, and we will fill it by a formula. So what we said is that using the fair as reference, for any cell, if the corresponding cell in the fair tab is missing, then the availability is 0. Otherwise, it's 1. Right? Just simple if-else logic. So we do matrix and field formula. So we say if fair is missing, you can don't have it. So missing here, use now. Then 0, else 1. Okay, so that's our availability. And we can now finally save this matrix file as the final result. Okay, so sometimes you may want to change everything here. For example, now you're developing a new fare system for your city, or you have made some changes in your route network, so you want to run the TransitSkim and everything all over again to generate another matrix file, so that you can run the 4-step approach again to compare all things like that. So here I'm going to show you a little bit how to change things, which will be very easy. So the first thing, you can bring this table back. A very easy thing to do will be to change our transfer there, right here. So you can just change it to whatever value you want directly on the table. So here I'm changing train to bus is $2 and the bus to bus is $1, whatever you want. And also for your own project, you can grab this mode transfer table or mode table files from the tutorial folder of the software and directly modify on it for your own project, so that you don't have to build these tables from scratch. The biggest advantage is to use its column or its field structure, so that you don't need to worry about the name of the fields, because sometimes it's kind of strict. I have shown you before. So after making these changes, then you can go to Transit. Close this. You can go back to make the root system as the working layer in here, and then go back to Transit and the settings again, mode, and so now it will need to update the information of mode transfer table here, and click OK, and do the skimming again, switching this to node, and do skimming. Select the variables and click OK. Alright, so that's the thing you need to do. Otherwise, if you say, okay, forget about these delicate things, I'm just gonna change my fare system in a quick and dirty way. So now let's say this fare, I will rewrite everything. What I'll do is that the fare will be dependent on the in-vehicle travel time. So if it's something like between 0 to 5 minutes, it's $1. Between 5 to 10 minutes, it's $2, and 10 plus minutes is $2.5, something like that. If you want to do that, then you can just directly overwrite our matrix of fare right here. So we can do again matrix fill and fill by formula, and we can type the formula. I have it right here. Might be a little bit different. Okay, here I'm doing it based on the in-vehicle distance. So we can come back to get the scheme again. So transit skimming, just to do this all over again. We can have the fare, in-vehicle travel time, wait time, the number of transfers, in-vehicle distance. So this will be our reference. So the system will be in-vehicle travel distance from 0 to 2, this is $1.5. 2 to 5 is $2. 5 plus is $2.5. So we click OK and OK, and the same name. Okay, let me give it a new name then. So now in the tab we would have the in-vehicle distance, and we would overwrite our fare matrix. To fill the formula, and I'm going to copy this formula I have here. Okay, so what it says is if fare is nil, then like this, then it's not available. So still now. Otherwise, if the corresponding cell in in-vehicle distance is smaller or equal to 2, then $1.5. Otherwise, between 2 and 5 is $2. Otherwise, it's $2.5. That's it. And we do OK. Now we overwrite the fare system just by the result of in-vehicle distance. So we can say this is roughly a distance-based fare system. Okay, you can be creative in setting up this fare or whatever policy of your transit system, and there are more advanced tools that I have not shown you, so you can have fun with that. Alright, so anyway, this matrix of all these features is our transit skimming results, and this is what we want for mode split. I hope the picture is clear in your mind now, just to help you connect everything. So that's all for our tutorial today. Thank you.